Mabuhay! I am Junior James JAPINAN, a BS IT student from Section C, and I am the first reporter in our group. By the way, a pleasant day to all of you. To you, Sir Danver Palmiano, to you, my dearest classmate, to my co-reporters, and to other people who are watching our presentation right now, good day. Now, me and my co-reporters will be explaining and discussing to all of you what a database is. So without further ado, let's get just started. So our first topic is database. So what comes to your mind when you hear word database? Do you have an idea about it? Well, if you haven't, don't you worry guys, because we will try our best to explain it to all of you what a database is. So what is database? A database is an organized collection of structured information or data, typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. Together, the data and the DBMS, along with the applications that are associated with them, are referred to as a database system, often shortened to just database. So basically, database is collection of information or data that is stored in a computer system. Data within the most common types of databases in operation today is typically modeled in rows and columns in a series of tables to make processing and data querying efficient. The data can then be easily accessed, managed, modified, updated, and controlled and organized. Most databases use structured query language or SQL for writing and querying data. So later on guys, I'll be explaining to you what does this SQL means. So now let's go to the different types of databases and we will discuss it. So the first type of database is flat file database. A flat file is one that stores a representation of a simple database, which is known as a flat file database. Flat files typically comprise text files with no markup, representing relational data by separating it with a comma or other delimiter. This distinction makes flat file databases different from relational databases, also known as SQL databases, which technically use multiple tables to store information. So flat file database is just a one table. So as you can see in the image or in the table, it composes of columns and text. For instance, it's written here the patient ID, the name, the DOB or the date of birth, gender, phone, doctor ID, doctor, and room. So that's the meaning of flat file database. So the second type is non-relational database. Non-relational databases, often called NoSQL databases, are different from traditional relational databases in that they store their data in a non-tabular form. Instead, non-relational databases might be based on data structure like document. A document can be highly detailed while containing a range of different types of information in different formats. This ability to digest and organize various types of information side by side makes non-relational databases much more flexible and relational databases. So as you can see in the table or an example, it's just like a document style or written in a document form. So it's written here the ID, the name, the address, the date of birth, the doctor name, office name, and so on and so forth. So the difference of non-relational to the flat file is that flat file is a one table. Compared to this non-relational, it's just a non-tabular format. So that's it. And the last type of database is relational database. A relational database is a type of database that stores and provides access to data points that are related to one another. Relational databases are based on the relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in the table is a record with a unique ID called the key. The columns of the table hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish the relationships among data points. So as you can see in this table, it shows relational database where each columns or table has their own value that also holds attributes to the data. In addition, relational database is different from those two types, which are the flat file and the non-relational, because relational database, they are connected with each other. On the other hand, flat file, as what I have mentioned, they are composed of one table, while the non-relational is written on a non-tabular form. As I promised earlier, I will explain it to all of you what does this SQL stands for and what's its definition. So SQL is a structured query language. It is a programming language used by nearly all relational databases to query, manipulate, and define data, and to provide access control. SQL was first developed at IBM in the 1970s with Oracle as a major contributor, which led to implementation of the SQL ANSI or ANSI standard. SQL has spurred many extensions from companies such as IBM, Oracle, and Microsoft. Although SQL is still widely used today, new programming languages are beginning to appear. So SQL, it is a programming language that used in different companies, for instance, IBM, Oracle, and Microsoft, which also very useful nowadays. So now let's move on to the second topic, which is a simple relational database example. So what is a relational database? A relational database is a collection of information that organizes data points with defined relationships for easy access. In the relational database model, the data structures, including data tables, indexes, and views, remain separate from the physical storage structures, enabling database administrators to edit the physical data storage without affecting the logical data structure. So a relational database, it is a collection of information that organizes data points. In the enterprise, relational databases are used to organize data and identify relationships between key data points. They make it easy to sort and find information, which helps organizations make business decisions more efficiently and minimize cost. They work well with structured data. So basically, that's what relational database is. So next, how does a relational database work? The data tables used in a relational database store information about related objects. Each row holds a record with a unique identifier known as key, and each column contains the attributes of the data. Each record assigns a value to each feature, making relationships between data points easy to identify. The standard user and application program interface API or API of a relational database is the structured query language. SQL code statements are used both for interactive queries for information from a relational database and for gathering data for reports. Defined data integrity rules must be followed to ensure the relational database is accurate and accessible. So relational database work through the information that about related objects, that each row holds a record with a unique identifier called key, and each column contains attributes to the data, and each record assigns value to each feature. A user can get a database report showing the data they need. For example, a branch office manager might want a report on all customers that bought products after a certain date. A financial services manager in the same company could, from the same tables, obtain a report on accounts that need to be paid. When creating a relational database, users define the domain of possible values in a data column and constraints that may apply to that data value. For example, a domain possible customers could allow up to 10 possible customer names, but it is limited in one table to allowing only 3 of these customer names to be specifiable. So in this table, it shows an example of what a relational database is. So as you can see, it is composed of columns, which stands for attributes, and rows, which stands for record or tuple. For you guys to have more idea and to be more enlightened about our topic, here's an example video. So please watch it.
Find exactly what you're looking for with a relational database. A relational database is comprised of tables of data that can be reassembled in different ways, as opposed to in a hierarchical file format. Each table includes columns of data categories or attributes and rows, also called records or tuples. Each row contains unique data or a key. Each table has a primary key that defines its information. For example, a typical business order entry would include a table that described customers, the primary key, with additional columns for names, addresses, phone numbers, and so forth. Another table within the relational database could describe an order number being the primary key, with columns for product, customer, sales price, and so forth. Users can manipulate relational databases to find the view that fits their needs. For instance, a manager could obtain a report just for outstanding accounts, or a report from the same table that only shows orders placed within the last week. Structured Query Language, or SQL, is a standard user interface for querying relational databases and gathering data for reports. Relational databases enable users to easily categorize and store data that can later be searched and filtered to find specific information for reports. That's the main advantage. Other benefits revolve around accuracy, flexibility, collaboration, trust, and security. Popular relational databases include Microsoft SQL Server, Oracle Database, and MySQL. What's your experience with relational databases? Let us know in the comments, and remember to hit that like button.
So there you go, guys. That's the first and second topic of what database is, its meaning and definition, its types, and a simple relational database example. However, our discussion is not yet over because Marjorie GAYOLA and Angeline HIMO will also explain it to all of you how individuals involved with a database management system, the evolution of database management system, and the advantages and disadvantages of database management system.
Thank you, Mr. JAPINAN. Now let's proceed to the third topic, which is all about the individuals involved with a database management system. So let's begin. Many persons are involved in the design, use, and maintenance of a large database with a few hundred users. Here we will consider people who may be called actors on the scene, whose jobs involve the day-to-day use of a large database. So the first individuals who are involved with a database management system are the database administrators. So what does a database administrator do? So they are the ones who will be administrating the primary database and secondary DBMS and related software because it is the responsibility of the database administrator or DBA. The DBA is also responsible for authorizing access to the database, for coordinating and monitoring its use, and for acquiring software and hardware resources as needed. So when we say database administrators, they are the one who will be administrating the primary and secondary DBMS. The second one are the database designers. So what does a database designer do? So database designers are responsible for identifying the data to be stored in the database and for choosing appropriate structures to represent and store this data. Database designer typically interact with each potential group and users and develop a view of the database that meets the data and processing requirements of this group. So when we say database designers, they are the one who will be designing the database. Third one are the end users. So end users are the people whose jobs require access to the database for querying, updating, and generating reports. The database primarily exists for their use. There are several categories of end users, so we have four. So the first one are the casual end users. They occasionally access the database, but they may need different information each time. They are typically middle or high level managers or other occasional browsers. So when we say casual end users, they are the middle or high level managers or other occasional browsers. The second end users are the naive or parametric end user. So their main job function revolves around constantly querying and updating the database using standard types of queries and updates that have been carefully programmed and tested. Bank tellers, reservation clerks for airlines, hotels, etc., are the example of naive end users. So when we say naive or parametric end users, they are the bank tellers, reservation clerks for airlines, hotels, and etc., because their main job is constantly querying and updating the database. The third end users are the sophisticated end users. So sophisticated end users include engineers, scientists, business analysts, and others who thoroughly familiarize themselves with the facilities of the DBMS so as to implement their applications to meet their complex requirements. So let us remember that sophisticated end users are the engineers, scientists, business analysts, and others because they thoroughly familiarize themselves with the facilities of DBMS. And last but not the least are the standalone users. So they maintain personal database by using ready-made program packages that provide easy-to-use menu or graphics-based interfaces. So examples of standalone users are the online library system, ticket booking systems or ATMs, and etc. So to recall the end users, they are the casual end users, the naive or parametric end users, the sophisticated end users, and the standalone users. And the fourth individuals who are involved with the DBMS are the software engineers. System analysts determine the requirements of end users, especially naive and parametric end users, and develop specifications for canned transactions that meet these requirements. Application programmers implement these specifications as programs, then they test, debug, document, and maintain these canned transactions. Such analysts and programmers are called software engineers. So when we say software engineers, they are the analysts and programmers. Now let's proceed to the fifth topic, which is all about the evolution of database. So let's begin. Data modeling and databases evolved together, and their history dates back in the 1960s. So what do we mean by data modeling? Data modeling is the process of creating a simple diagram of a complex software system using text and symbols to represent the way data will flow. So that is the definition of data modeling. Next, the database evolution happened in 5 waves. The first wave consisted of network, hierarchical, inverted list, and in the 1990s, object-oriented DBMSs. It took place from roughly 1960 to 1999. Next, the relational wave introduced all of the SQL products and a few non-SQL around 1990 and began to lose users around 2008. Next, the decision support wave introduced online analytical processing, or OLAP, and specialized DBMSs around 1990 and is still in full force today. Next, the graph wave began with the semantic web stack from the World Wide Web Consortium in 1999, with property graphs appearing around 2008. And lastly, the NoSQL wave includes big data and much more. It began in 2008. So let me introduce to you the illustration of the evolution of database. So as you can see here in the illustration, we have the 5 waves of the evolution of database. So these are the pioneering DBMS technologies, the relational empire, the multidimensional, the graph, and the NoSQL waves. So as you can see here in the illustration, the pioneering DBMS technologies happened in 1960s up till 1990s. The relational empire happened in 1980s up till today in the 2010s. Then the multidimensional happened in 1990s up till now. The graph wave happened in 2000s up till now. And lastly, the NoSQL, which happened in the early 2000s up till now. So that's it for my report, and let us proceed to the report of Ms. Angeline HIMO, which is all about the advantages and the disadvantages of DBMS approach.
Hello everyone, I am the last reporter of Group 7 and I am going to discuss the advantages and disadvantages of a database management system. Then first I will discuss the advantage. First advantage of DBMS is improved data sharing. The DBMS helps create an environment in which end users have better access to more and better managed data. Such access makes it possible for end users to respond quickly to changes in their environment. So the data sharing is the primary advantage of DBMS. And these systems allows users to share data and to multiple applications and users. So what will happen if that the database can share multiple applications and users? So the data stored in one or more servers in the network, and some software lacking mechanisms that prevents the same set of data from being changed by two people at the same time. So while the file system doesn't have this a capability, only DBMS, but with the help of this capability, members of users can access as well as to manage the data in efficient manner. The next advantage is improved data security. The more users access the data, the greater the risk of data security breaches. Corporations invest in considerable amounts of time, effort, and money to ensure that corporate data are used properly. A DBMS provides a framework or better enforcement of data privacy and security policies. So in data security, when you allow your data to be shared with multiple users at the same time, at multiple times, and the chances of security breaches becomes very high. So the DBMS file system has many systems that they can do all any security threats if they exist. Next is better data integration. A better data integration, wider access to well-managed data promotes an integrated view of the organization's operations and a clearer view of the big picture. It becomes much easier to see how actions in the segment of the company affect other segments. So in better data integration, This advantage allows decision maker to access all the data they need, and it eliminates the manual effort of performing complex repetitive tasks, and also to eliminate the need for writing and maintaining point-to-point scripts. So that's it. Then let's move to the number 4 advantage, which is minimize data inconsistency. Data inconsistency exists when different versions of the same data appear in different places. So in minimize data inconsistency, the DBMS can reduce data inconsistency by minimizing isolated files in which the same data are repeated. So we can minimize, or we can use constraint on the database to minimize data inconsistency. So the next advantage is improved data access. The DBMS makes it possible to produce quick answers to ad hoc queries from a database perspective. A query is a specific request issued to the DBMS for data. Simply put, a query in a question, and an ad hoc query is a spur of the moment question. The DBMS sends back an answer to the application. For example, end users. So improved data access it helps increase an organizational accessibility to data, which in turns helps the end user share the data quickly and effectively, and across the organization. Then the management system helps get solutions to database queries, thus making data access faster and more accurate. Then the last advantage of DBMS is improved decision making. Better managed data and improved data access make it possible to generate better quality information on which better decisions are based. The quality of the information generated depends on the quality of the underlying data. Data quality is a comprehensive approach to promoting the accuracy, validity, and the timeliness of the data. While the DBMS does not guarantee data quality, it provides a framework to facilitate data quality initiatives. Increase in users' productivity, the availability of the data, combined with the tools that transform data into usable information, empowers end users to make quick, informed decisions that can make the difference between success and failure in the global economy. So in improved decision making, it allows business to make equality business decisions, which will promote the growth of the organization. And with better data management system and procedures comes higher quality information. And then comes higher quality information helps in making data faster decisions in an organization. So that's all the advantage of DBMS. Now we will proceed in disadvantage of DBMS. So the first disadvantage of DBMS is increased cost. Database systems require sophisticated hardware and software and highly skilled personnel. The cost of maintaining the hardware, software, and personnel required to operate and manage a database system can be substantial. Training, licensing, and regulation compliance costs are often overlooked when database systems are implemented. So this is the first advantage of DBMS, which is increased cost. This is because for DBMS, it is mandatory to have a high-speed processor and also a large memory size. After that, nowadays there is a large amount of data in every field, which needs to be stored safely and with security. The requirement of this large amount of space and high-speed processor need expensive hardware and expensive software too. So that there is a requirement for sophisticated hardware and software, which means that we need to upgrade the hardware which is used for the file system. And then hardware and software both require maintenance, which cost very high. So that's the increased cost. Next is management complexity. Management complexity. Database systems interface with many different technologies and have a significant impact on the company's resources and culture. The changes introduced with the adoption of a database system must be properly managed to ensure that they help advance the company's objectives, given the fact that database systems hold crucial company data that are accessed from multiple sources. Security issues must be assessed constantly. As we all know, nowadays, all companies are using the database management system as it fulfills a lot of requirements and also solves the problem. But the problem arises. That's all this functionality has made the database management an extremely complex software. For the proper requirement of DBMS, it is very important to have a good knowledge of it by the developers, the designers, and also the end users. This is because if any one of them does not acquire proper and complete skills, then this may lead to data loss or data failure. And these failures may lead to leads to a bad design decision due to which there may be serious and bad consequences for the organization. So these complex systems needs to be understood by everyone using it, as it cannot be managed very easily, and also it requires a lot of management. So that's the management complexity. Then the next disadvantage is maintaining currency. To maximize the efficiency of the database systems, you must keep your system current. Therefore, you must perform frequent updates and apply the latest patches and security measures to all components. Because database technology advances rapidly, personal training costs tend to be significant. Vendor dependence. Given the heavy investment in technology and personal training, companies might be reluctant to change database vendors. So, in maintaining currency, this is very necessary to keep our system current efficiency, which is one of the biggest factors and needs to be overlooked, must be maximized. That is so that we need to maximize the efficiency of the database system to keep our current system, to keep our system current. For this, frequent updation must be performed on all components as new threats comes daily. So that's it. Then the last disadvantage of DBMS is frequent upgrade or replacement cycles. DBMS vendors frequently upgrade the products by adding new functionality Such new features often come bundled in new upgrade version of the software. Some of these versions require hardware upgrades. Not only do the upgrades themselves cost money, but it also costs money to train database users and administrators to properly use and manage the new features. So nowadays in this world, we need to stay up to date about the latest technologies, development arriving in the market. A frequent upgrade of the products done by the database management system. Vendors to add new functionality to the system. New upgrade of the version software often come bundled. Sometimes these updates are so fast that users find it difficult to work with that system because it is very easy to learn new commands and understand them again when the new upgrades are done. That's why all of these upgrades also cost money to train users, designers, etc. to use this new features. So that's all.
Hello, everyone. We are the Group 7, and I am going to introduce my co-researchers. The first reporter and researcher is Mr. Jumir James Al-Hapinan, who explained to us what the database is and also discussed about the simple relational database examples. The second reporter and researcher is yours truly, Marjorie M. GAYOLA, who explained to you the third topic about the individuals involved with the database management system, and the fourth topic, which is about the evolution of database. The third and last reporter and researcher is none other than Ms. Angeline Q. HIMO, who discussed to you the fifth topic about the advantages and disadvantages of DBMS approach. Let me also introduce the handsome advisor of ITC 100, Sir Danver Palmiano. So that's it for our report and presentation about database, and I sincerely appreciate your time and attention today. I hope you all learned and understood something from our report. Thank you all for listening. God bless.